Hi everyone, my name is Valentina Guatibonza Garcia and I'm a TA1 of the PPCR course. Today I will continue with a statistical test review that my colleagues already started in previous videos. Hope you enjoy it. First, I would like to tell you don't panic. Even though statistics seem hard, they are your friends. They will help you analyze your data and get fantastic results. This is the agenda for today. So first, I would like to start talking about categorical data. So just to recap, what is a categorical variable? It is a variable that does not have a numerical value. It can be nominal or ordinal. There is another nomenclature for nominal variables that is dichotomous or binary and non-dichotomous. We say a variable is dichotomous when there are two possible options, let's say yes or no, male or female, and you can code it using 0 or 1 values. A non-dichotomous variable has more than two options. What is your favorite color, for example? On the other hand, ordinal variables follow an order, but the distance between the categories is not equal, or we can quantify it for sure. So there are some advantages and disadvantages of using categorical variables or categorizing your continuous variables. For example, when you use certain laboratory value and you classify it in high or low according to a cutoff value. The main advantages are that this simplifies the statistical analysis as well as the interpretation and allow us to get clinically relevant conclusions. However, much information is lost, sometimes we lose statistical power, and we might deal with an increased risk of false positive results. Moreover, there might be some underestimation of the variation between the groups we are comparing. Now, having said that, I would like to check what are the available tests to analyze categorical data. So first we have to check if our data is unpaired or paired and how many groups we are comparing. If data is unpaired and we are comparing two groups, we can choose a chi-square test or a Fisher-Exact test. If we want to compare more than two groups, we will go for a chi-square test. If data is paired, let's say before and after, we are comparing two sets, we use a McNemar's chi-square test. But if we are dealing with more than two sets, we use a Cochrane's Q test. I would like to clarify that the Fisher-Exact test is preferred when the sample size is too small and the cell count is less than 5. Moreover, a Fisher-Exact test will provide us with an exact p-value which is accurate for all sample sizes. I'll show you what I mean with cell count in the next slide. In order to perform a chi-square test, the recommendation is a sample size of minimum 30 observations or subjects, and no more than 20% of the cells of the contingency table should have an expected frequency of less than 5. I'll show you what I mean with expected frequency in the next slide. Now, I would like to give you some highlights about the chi-square test, which is the most popular one. Everything is based on a contingency table, which describes the result of two or more groups that are being compared, and the outcome is a categorical variable. To perform a chi-square test, we must keep in mind this formula, where we consider both the observed and the expected values for each cell in the contingency table. These are some values we need to calculate before calculating the chi-square. We must calculate the expected frequency for each cell, the degrees of freedom, and finally, we have to keep in mind the chi-square distribution table that you can find online. The null hypothesis is that there is no association between the independent and the dependent variable, while the alternative hypothesis states that there is in fact an association between this variable. So first, we have to calculate the expected frequency for each cell. Then we calculate the chi-square according to the formula. Then the degrees of freedom, we state the alpha level, which is usually 0.05. We use the chi-square distribution table to find the critical value based on the degrees of freedom and the alpha level. And if the calculated chi-square is greater than the critical value, we can reject the null hypothesis. So, as I mentioned before, if the calculated chi-square is greater than the critical value in the table, we reject the null hypothesis. But if the calculated chi-square is smaller than the critical value, we fail to reject the null hypothesis. This is the rationale of using this test. However, once you understand it, you can always use Stata to calculate it. Now I am going to talk a little about nonparametric tests. They are defined as tests that does not assume the distribution of the data. So there are two cases for using them: when the distribution of our data is not normal, or when we are comparing two or more groups with an ordinal outcome. Generally, we can assume that our data is not normally distributed if we have a very small sample size, and it is not possible to determine the distribution. Even though there is no fixed number to define a small sample size, we use nonparametric tests for groups of 6 or less. However, and following the central limit theorem, when we have more than 70 subjects in our sample, the use of parametric tests is acceptable. For sample sizes that are in the gray zone or in the middle, we can use some other tools to verify if our data is normally distributed, such as the Will-Shapiro test, or we can use histograms or the analysis of mean and median. As I mentioned before, there are cases where our outcome variable is ordinal, which means there is an implicit order. However, the distance between the categories cannot be quantified or is not regular. And even though the use of tests for categorical data like chi-square might seem logical, this can disregard information about the order, so we prefer to use a nonparametric test. Now I would like to show you some facts that you have to know in order to use nonparametric tests and how to choose. These are the assumptions that need to be checked. First, that the sample was drawn randomly from a large population, and second, that each observation or pair of observations was independent of each other. So, when comparing a continuous variable between two groups with a normal distribution, the observations can be independent or paired. If the groups being compared are independent, we use a Mann-Whitney test, which will be the equivalent of a t-test for independent groups. But if the groups are dependent or related, we must use a Wilcoxon rank sum test. Now, if we are comparing more than two groups, we must use a test called Kruskal-Wallis, which will be the equivalent of an ANOVA test used for data that is normally distributed. Finally, I would like to give you some tips that help me a lot and I hope will help you. This book, 262 questions for deeper statistical learning through questioning, it's amazing. Also, some of the TAs are doing stata sessions to learn how to use it step by step. These sessions are very helpful. To conclude, the most common test to analyze categorical data is the chi-square test. Nonparametric tests are used when data is not normally distributed or when the outcome is an ordinal variable. It is key to know your data. What type of variables are you analyzing? And stata is a valuable tool to analyze your data. Go step by step in order to learn how to use it. So thank you. Thank you so much.